All right, what we're going to do here is we're going to look at how we're going to do graphics with GNU Octave and also some other code that we can do as we progress. I'm going to start with, I'm going to look at a function that's called the sync function, which is defined as sine of x divided by x. And so the first thing I want to do is I want to plot this. I want to see what it's doing. We know it has a problem at 0 because anything divided by 0 is undefined. So we're going to look at tools on how we can change this. So what I'm going to do is I'm going to open GNU Octave. And in GNU Octave, let me switch over here. I'm going to switch to all my windows. Well, we're going to get many windows here, but I'll come over to GNU Octave. We normally start in the command window. So let me clear my command window here as I was running some tests earlier. And I can navigate to any directory here. And so I'm going to create a new directory in my documents, and I'm going to call this Octave Scripts. And I'm going to change into Octave Scripts. So if the directory I'm in is listed, I'll be able to pull any file I have saved in here. So we're going to make a file to save. We're going to hit new file, and it opens up an editor. And the first thing I'm going to do is I'm going to file. I'm going to save this file as, and we're going to call it graph function. And so graph function, and it will save it as a .m file. And notice it appears over here in my window. So we'll do 1 semicolon to let Octave know that this is a script file. And the first thing I'm going to do is I'm going to define a function. I'm going to say f will equal f of x. And we'll say that the output values of f will be sine of x dot divided by x. And then I'll end my function using the end function command. And I'll test code often. I'll save this, and I'll come back to my command window, and I'll type in graph function. And I get no errors. In fact, I've loaded this sync function in. I could go f of 1, and I get the answer that would have been for the sync function at 1. I could do f of pi, and I get the answer, roughly the answer. It sinks down to 0, but this is 3 times 10 to the negative 7th. So we have this function defined in memory, but let's work on graphing it now. So what I want to do is I want to graph it over a range. So I will have my max x, and I think I'll want to graph. I will graph out to 4 times pi right now. My min x will go from -4 times pi. And I'll make an x variable. Since I'm using x a couple places, I'm going to distinguish my function x from my code x by putting underscores here. This isn't needed. This is just for me visually. And I want to say x is going to be my min of x in steps of 0.01 to my, I will do steps of 0.05 to my max x. And then I'm going to plot x on my x-axis and f of x on my y-axis. And hopefully I've got what I need in my code here to give a plot. So I'll come back over, and I'll try my graph function. And I must have mistyped, which happens a lot. Oh, yep, I used a lowercase x here, and I want to use an uppercase. So we'll file and save. We'll file and save if I hit the right keys. Come over here, and I'll try to run it again. Well, it looks like I'm having an uppercase, lowercase. Yep, max x has a double x in it. I am the king of typos, that's why I run often. so that I can correct my typos. And there is the graph of the sync function. It pops up. Notice I got all my x variables, so I'm going to fix that slightly. And so sync is a wave with decreasing amplitudes. So I'll come in and fix the last thing. If I don't want a line to print out, I'll put a semicolon after it. And this should give me enough. I'll run this again. I'm still getting my output for my X commands. So let me look here. Let me wrap these in a bracket. Ah, there's where it is. I have to put my semicolon here. Semicolons, if you don't have a semicolon at the end of the line, it'll print it to the screen. And so now I have a program that can graph any function I want to see. So if I come back to my editor, I'm going to walk down the basics. We need to define the function. So I'm going to call my functions f. It's going to take in one variable x, and the output is going to equal the sine of x dot divided by x, and that'll end the function. For graphing, I define my maximum x value and my minimum x value. I load them into a vector or a list from the minimum to the maximum in steps of 0.05. And then I use the plot function to plot my x by my y values. And this will get us a graph for the functions that we do. I'm going to do some more videos around what we can do with the sync function. But what's nice is we can come back in here and we can ask for any other function to be plotted here. So if I come in and change this f to sine of x, I'll get a sine of x. So this is a good starting program for our graphs.